This video is about exercise 502 on stationary points. It is revision of year 11 work. So we saw in year 11 that there are 3 different types of stationary points. So you've got this one right here, which is a local minimum. So we can see right there that the gradient is equal to 0. If I drew a tangent line, it's horizontal. So at a local minimum, the gradient is equal to 0. Just to the left, around here, the gradient is negative. So you get a negative number there. And just to the right, you've got a positive. Now if I drew those gradients, to the left it's negative, for the minimum it's horizontal, it's 0, and for the right it's positive. And that gives us a nice picture of a minimum. If we look at a maximum, in the same way, right at the point, if I draw on a tangent, it is horizontal, so the gradient or the derivative is 0. Just to the left, it is positive, and just to the right, it is negative. So if I draw those gradients, a positive gradient goes that way, a 0 gradient goes like that, and a negative gradient goes like that, you get a picture of a maximum. You can also get stationary points at points of inflection. So this is a horizontal point of inflection. Right here, if I draw on a tangent line, it is horizontal, which is why we call it a horizontal point of inflection. So the gradient at the point of inflection is 0. Just to the left of this one, it's positive. Just to the right of this one, it's still positive. So we get this shape for a point of inflection. If it is increasing, if it's a decreasing point of inflection, at the point of inflection, the gradient is 0, horizontal. Decreasing here, so the gradient is negative. Decreasing here, so the gradient is negative. So if I draw those on, negative gradient, horizontal gradient, negative gradient, we get a horizontal point of inflection. There are other types of points of inflection, and we'll learn more about these in a further exercise. Just a little note about a graph and some naming. Maxima and minima are the plural of maximum and minimum. This point A is what we call a global maximum because it's the highest point on the whole curve. There's no arrow, so the curve does stop at that point. The domain has possibly been limited in some way. Point A is a global maximum, whereas point C is what we call a local minimum, or sometimes called a relative maximum. That is a local or a relative maximum, not a global maximum. Just in this area, it is relatively maximum compared to everything else. Point B is a local or relative minimum, and this particular curve has no global minimum. This arrow tells us it keeps going and it keeps going. So there is no global minimum.